Hello everyone and welcome back. In last videos of this series, we have configured the URDF file for this robotic arm which was created using SolidWorks. We launched it in the gazebo. We wrote some controllers. This is just a screenshot, but you can see my last videos. We created our own Move It workspace. We added that our robot arm URDF package generated from SolidWorks in the SRC folder of the Move It workspace. Then the package was containing only the simple URDF and the STL files. So we first basically modified the CMake_list.txt and package.xml file to add some dependencies. Then we modified the URDF file to add the transmission tags and the gazebo controller. Then we return a joint trajectory controller.yml file to control the joints of the robot. And we return a launch file, custom launch file to load everything in a single terminal. So in this tutorial, we will be creating a Move It package which will control the robotic arm using inverse kinematics and control the joints by planning the joint trajectories as per the environment around it. So just follow me along. So first of all, you need to launch the Move It Setup Assistant, which you need to do it using terminal. So open a terminal. Move It is installed by default with the ROS. If you don't find it, you can install it using the instructions given in the document attached in the description. So once you come here, before launching the Move It Setup Assistant, you need to source the bash file of your Catkin workspace. So first do cd your Catkin workspace name. It will be move it underscore workspace. If you followed me in the tutorial here, move it workspace and just move it workspace and press enter. Once you are in the directory, type the command source level, type this and press tab, sct, press tab setup dot bash, press enter. Once you source the bash file, we will launch the Move It Setup Assistant. So run the command ROS launch move it underscore setup. You can type this and press tab. Sorry, I written it wrong. Move it underscore setup assistant space setup assistant. You can type some initial word and press tab. It will autocomplete and press enter. It will launch a GUI like this. Do not close this terminal, otherwise your move it will close. Just minimize it and expand this. Now we need to create a new Move It configuration package. Click on this. Click on browse to browse our URDF file. Now go to home directory. Find the your Catkin workspace. Mine is Move It workspace. If you have followed me in this tutorial, you will be having same workspace name. Go to that. Go to the SRC folder. You will find here the Robotarm URDF package that we configured in this tutorial. Click on this. Go to URDF file. This is the URDF file that we configured in this tutorial. Just select it and click on open. Once you open it, uh, you will find here the path is loaded here. Just click on load files. So it will show you the here the preview. You can drag it using middle mouse button and rotate it by pressing the left mouse key. So if you don't get this preview, something wrong is in your URDF. You need to check your URDF file. So for me, it is good. Next, click on self collision. Here, set this bar to high and click on generate collision matrix. So it will just check like which links will never collide with each other, and it will disable the solver or that collision detection for those links. For the like you can see here link A and here link one, like it has created the groups that will never collide with each other. You don't need to take attention to this. Just go to virtual joints. If you haven't added that virtual joint, you need to add. But again, if you do this, you need to change your URDF after this. We will skip that. We will go to planning groups. Now here, as we written a different controllers for our robot arm and the hand effector in this tutorial, you just need to create two different groups for robot arm and the end effector. So click on add group, name it as arm underscore group. Sorry, arm group. In the kinematic solver, select KDL kinematics plugin. It is the default one. You can check the use of others on the ROS wiki pages. Now keep the search resolution as it is, the parameter like this as it is. In the group default parameter, you can select RRT, which is the by default planner. Now go to add joints. Here you need to add everything from base linked to I think you need to add from link 1 to link 5. So just press Control key on your keyboard and select up to link 5. As our base link is fixed, so we will not add any group for that. Just add it here and click Save. Like you need to press this key to add them to the selected move group or joint. Click on Save. We have added one move group. We need to add another for the end effector. Here, give the name and just like it is the end effector, so we will name it as a hand. You can name anything as you want. For this, we will not select any kinematic solver as it is a basic mechanism. Here, no planner we will select. We will just add the joints. Select joint 6 and joint 7 and click on this button to add them into the joint group and click on Save. You can see here two groups are created. Arm group, it has joint 1, 2, 3, 4, 5. Hand joints has joints 6 and 7. Now click on robot poses. So what we do in robot poses is we predefine some positions like you may have seen in the 3D printers, like when you do a reset, they go at the position 0, 0 at X, Y and Z axis. So similar kind of thing we will be doing here. So click on add pose. So first we will select the planning group as this robotic arm. Before doing that, we will create it for the hand. So for hand, you can see like one joint is completely closed and one has completely open because the range of motion is like one is from 0 to 0.03 and another is from minus 0.03 to 0. So here we will save this as it is. We will name it as a hand closed and click on save. Again, click on add pose, select hand group only, click on hand and type hand open and just open this joint to its maximum and this to its minimum. You can see like the robotic arm or sorry, the robotic gripper is completely open. Now save it. So we have completed adding the poses for the end effector. Now we will add the poses for our robotic arm. So in this, click on, we have clicked on add a pose. Now select the arm group as the planning group. Name it as all zeros. Name it as zero pose and save it. So it is the basic like zero location of our robot. All the joints are at their zero state. Now again add another pose. So now we will make the state like all the joints will be like the robot arm will like appear as a straight. So go here and take this to like so as you can see here, it is moving reverse. So it is the error in our URDF file. So if this happens, what you need to do is you just need to cancel now, and you need to go to your Catkin workspace and open that URDF file that we used for the Move It Assistant. So open this URDF file. So here, if you go into the add pose, you can see like we have the error with the joint 3. The joint 3 should rotate like it should, as it is rotating like this, it should rotate reverse. It should rotate like this. So currently its zero position is this and its 3.142 is like this. So what we need to do is here you can see it is moving in positive, like it is moving clockwise if we give this positive value. So what we need to do is we need to change the range of this joint to from 0 to 3.142 to minus 3.142 to 0, so that it will take this like minus 3.142 is like reverse to this, so it will move from this to this. Okay, so just go to your URDF, locate the joint 3 in your URDF file. Like you also need to check other joints if there is any error. We will do that also. So you can see here is the joint 3. So here the lower limit is 0 and upper limit is 3.142. You just need to type it here like I will just give a simple trick. Just take this value, Control X, and paste it here and just give it a negative sign and then add 0 value here. Before closing this URDF, just again go to Move It Setup Assistant and check if other joints are working correctly. So this is working correctly. Only I have problem with this. This is also working correctly as desired, and this joint is also working correctly. Again, you can see like it is only rotating in 180 degrees, but I want it to rotate about 360 degree. So again, I will go to joint 1. Again here joint 1, and I will double this value. It is like 3.142. It means it is 180 degrees. So we just need to set it to 360 degree. So type it here like twice the value, 284. Okay, 6.284, and press save. And now we are done with the editing the URDF file. So we can close this. Again, uh, what here we have done is we need to start again. So just cancel it, and you need to go to that terminal and press Ctrl C, and just press the upward arrow key. So the command will appear again. Press enter. Again, do the same steps. Create new package, browse, go to your Catkin workspace. Load the files. It is successfully loaded. Go to self collision, set it to high, generate collision matrix, click on virtual joints. We need to skip this. Go to planning groups. You can just expand this. Click on add groups. Name it as first of all we will add sorry, we will add a end group for this end effector. So type here hand. Don't select any kinematic solver. Just don't select the planner. Just add joints and select these two joints which are from the end effector and add them into the group. Click on save. Next, we will add a group for the robotic arm. Name it as robot. Sorry, you can name it as just arm underscore arm group. Select the kinematic solver as KDL, KDL kinematics plugin, which is the default. For the planner, select RRT, which is again default, and click on add joints. In a robot arm, add joint 1, joint 2, joint 3, joint 4, joint 5. The base joint is fixed, so we will not add into the planning group. And next, click on save. We have added our planning groups. Like hand group contains joint 6, 7, and arm group contains 1, 2, 3, 4, 5, 6. This is because we have written different controllers for these two groups. Like for end effector, we have different controller, and for arm, we have different controller. As you can follow this tutorial here for knowing about that. Next, go to robot poses, click on add poses. So this time your URDF should function properly. So again, we will add a pose and closed. We are just defining the default poses. Click on save and we will add another pose for the hand groove that will be open state as explained at the starting of this video. We will name it as hand open and click on save. Again, click on add pose. This time we will add it for the arm group. You can see the links in the move group are getting highlighted as red. Now you need to save this state as it is as a zero state. So we will name it as zero pose. So it states that our all joints are at zero state or zero angle. You can see here. Click on save, add another pose. We are creating this pose so that we can call it from any Python script. So now we want to make this robot straight up. So what I mean by Python script, we can write a Python script to control this robotic arm, and in that we can call this robotic poses to set the robot in any state. We can also give the joint angles, but it is always convenient to have some default poses. So straight up means we need to make this robot arm stand up completely. So this is the joint 3. We need to set it to like minus, as we have set it like 0 to minus 3.142. We will set at minus 1.572 and click here. So it is now at 90 degrees. Again, uh, we need to do this same here, minus 1.572. So it will again go to straight up. So save this. Now we will again add another pose like to pick some objects. Like we will now set it manually. You can use these sliders. Like later on, we can just give use the inverse kinematics to just take it to any coordinate. Like at the base of this robot, there will be 0, 0, and you can take this end effector at any position from that origin, like anywhere you want. That will be done using a Python script, which is called as node. So we will save it. Like we will also like rotate this to 90 degree, 1.572 radian, and click on save. Okay, so I will name it as like pick object quotes and click on save. Now the next we will add is lift object pose, and we will just lift the object just like we had lift the object and save it. And again, we will add another position. Like again, you can see like this joint is now rotating 360 as we modified our URDF previously in this video. So I will again set it here like 3.142 and name it as deposit or yeah, X. Okay, I will name it something like uh, opposite pose. You can name it anything, but I will just name it like this. Save. And again, I will add another pose. Place object it pose and just make the robotic arm to place the object there and save it. Now, these are the enough states for default states for our robot. We will go to end effector and we will add a end effector. We need to name it as like and EE. We have named the group as hand, so we will name it as hand end effector. So end effector group, we will select this hand, which was the end effector group. Parent link, we will select it as a link 5 because the end effector is connected to the link 5. A parent group, you can name it as blank, or you can select that ARM group. I will keep it as blank. Click on save. Passive joints are the joints which are never controlled or powered, but we have all joints controlled. So we will do nothing here. Go to ROS control. Again, you can add some controllers here, but I prefer them to write manually. In simulation, if you want to generate a new URDF, you can copy this and replace the URDF, but we will not do that because we have already configured our URDF because this will create a lot of errors if we use this. Go to 3D perception. We are not using this. Go to author and just if you don't add author and email, the Moovit will not allow you to generate this package. So you need to add it here. Email ID, it can be anything. It don't check whether it is a valid email ID or not, but it is good. Like it gives the information of the author. So sorry, I will add one dummy email ID. Okay, and go to configuration files. And now here we are already in our Moovit workspace. Just take it into the SRC folder. You can also browse from here. Now, as I had typed, I am already in SRC, and I will cancel and just give slash and type the folder name or the package name which you want to generate. So I will name it as Moovit robot underscore arm underscore sim and just click on generate package. So it will give you a warning that no virtual joints have been added, but we will proceed. Click on OK. So configuration package generated successfully. So we are done with our package. In next video, we will write the controller for controlling the joints. Moovit controller we will add. You can check the generation status. You can come here and you will see here the Moovit package is added and it contains different like move group is created and different files are created. There are some by default files like gazebo.launch and demo.launch, and there is a config file, config folder containing different controllers. So in next video, we will see how to configure this package to control our previously created that RobotArm URDF package. So stay tuned and watch my next video. Thank you.